Okay, so welcome back, and now we're going to do an example, and we're going to use this function here, and we're going to find all the zeros and the maximums, the maximum value of the absolute value of r. Okay, so let's start with the zeros. So again, here we're going to set the equation equal to 0. So we're going to set r equal to 0. So we're going to have 2 sine theta is equal to 0. Okay, and of course this is equivalent because if we divide both sides by 2, we get sine theta is equal to 0. So when is sine of theta equal to 0? Well, this implies, well, we know that sine is equal to 0 whenever whenever theta is equal to 0. Or any multiple of pi, plus or minus any multiple of pi. So we can say that this theta will equal 0 plus or minus, pi times k. Okay. So what does that mean? Well, that means there's going to be zeros at the point 0, 0. So 0 comma angle 0, or it's going to be 0 comma plus or minus pi k, where k is an integer. Okay, so those are all the values or all the points where the radius is 0. Now what about the maximum? Let's find the maximum value of r. Okay, so now to find the maximum value of r, we find where sine is maximized. Okay, so where is sine maximized? Well, we know that sine is maximized at pi over 2 and any multiple of pi added or subtracted from pi over 2. So maximum of sine theta is equal to 1. Right? When does that occur? When pi is equal to, or not pi, when theta is equal to pi over 2 plus or minus any multiple of 2 pi. So what does that mean? It means that at these angles, what's the maximum value? In absolute, it's going to be 2, right? Because the maximum value of sine is 1 at these angles, so r, the absolute value of r, the absolute value of r is going to be 2. Okay, so let's use this to graph some points. Okay, so let's have our table. So we've got our theta. And so let's go down and use the typical angles, right? The angles that we're familiar with. Oh, no, pi over 3. Pi over 3. Pi over 2. And 2 pi over 3. Okay, so let's start with those. And so when we stick in 0, right? So you know our, oops, hold on a second. Got it mixed up. There you go. So we know when theta is 0, r is 0. Okay. We also know when theta is pi, r is 0. We know that sine is maximized at pi over 2, so we know this is going to have a value of 2. Okay. And so what happens at pi over 6? Well, this is where we plug this into our calculator. Now, the thing is we could use what we know about the sine function, right? So sine of pi over 6 is 1/2. So 2 times 1/2 is 1. So this gives us a value of 1. Now we see that the radius is now increasing, okay? And then what about the sine of pi over 3? So that's a sine of 60 degrees. And the sine of 60 degrees is going to be square root of 3 over 2. Which is going to be bigger than 1, but less than 2. So approximately 1.73. Okay, so 2 pi over 3. Well, 2 pi over 3 is a 60-degree angle, okay? And that's in the second quadrant. And sine is positive in the second quadrant. And so what happens? Well, this is going to be, again, square root of 3 over 2, or approximately 1.73. So it goes from 0 to 1, and then all the way up to 2, right? So it's increasing, the radius is increasing from 0 to pi over 2, and then it starts to go down, okay? And so this is going to be 1 over 1.73, and then at 5 pi over 6, it's going to be 1, and back to 0. And so you can see that if we graph this thing, right? So if we graph this thing on the polar grid, think about it. The radius at 0 is starting at 0. So let's have this. So it starts at 0. And it increases to 1 at pi over 6. Right? So at pi over 6, which is, again, 30-degree angle, it's at 1. So let's say about there, I guess. Well, more like there. And then at pi over 3, it goes to almost 2, right? Let's say about there. And then at pi over 2, which is 90 degrees, it's at 2. and then it starts going back down. And so as you plot these points, you get a circle, which is the same graph that we saw before. So this is how you would graph it, and again, knowing that from 0 to pi, it goes from 0 to 2 and then back down to 0. Now if we go to 2 pi, it's going to make another tracing of this circle. So in fact, one of the things that we're going to talk about later is that as we keep plotting, we start to notice patterns, and in this case, it's going to repeat this trace every pi. Okay? So that's going to be important later on. Okay. Have a great day.